Hey guys, it's Desiree. So for my project, my final project, I decided to focus on pendulums. Our book covered it in a couple different chapters, and it actually gave a lot of different information on it. Pretty much, went through the experiment process and what you can do with that. So my main focus on this project was just to see how I could go about using it in a classroom, which is why we're here after all. How could I use pendulums and also adhere, to the standards. So I looked them up, looked up the standards, and I could not find anything under the keyword pendulum. There was nothing that just said straight up pendulum. And so I looked further, and I found some that were actually based, or that focused more on, the workings of a pendulum. So, for instance, here, there was one in 3rd grade. Plan and conduct an investigation to provide evidence of the effects of balanced and unbalanced forces of the motion on the motion of an object. And then another one was, let's see here, make observations and/or measurements of an object's motion to provide evidence that a pattern can be used to predict future motion. And for the clarification statement, it actually said examples of motion with a predictable pattern could include a child swinging in a swing, and so on, which we know, that a swing is actually just a pendulum. So I decided to focus on those. Excuse me. So what I started out with was I went ahead and made, I researched online and, looked up different ways to use pendulums within a classroom, which I found there's not a lot out there. Which was kind of interesting. But I did find a picture of a frame, just like this one. I don't know if you guys can see it very well. You probably can. It's taking up the whole screen. But it's just PVC pipe. I went to the store, picked up the different pieces to put this together. And when I read about it online, it was actually being used for pendulum painting, which I'll get back to that later. But this is really a cheap way to create a frame to hang a pendulum from. I think all my pieces were maybe like $12, I believe is what I spent. Excuse me, I have a frog on my throat. So this is something that could easily be used in a classroom, and it's not going to break the bank. And, you could have one for each group. You could have multiple ones and not spend a lot of money on it. Anyways, so let's see here. When I was reading about it in the book, about the pendulums, and in our textbooks, it actually said not to get into the physics of how a pendulum works. Not to get into too much detail with that. And so, and I actually also found that the same was true in our standards. Technical terms such as magnitude, velocity, momentum, vector quality are not introduced at this level. But the concept that some quantities need both size and directions to be described is developed. So, it's not, both of these things are saying, don't get too technical with this. Don't, don't make it into a physics class. Don't make it more than what they can understand. So that made it interesting because, I had to go just basic, just have it very basic. And, since our books did go into it a lot, as far as how everything works, I just wanted to keep it basic. So I made this, and then I went ahead and I got some string. See that? Just some very, some thin string. This would be easy to hang up. Some tape to just tape it so that I wasn't having to tie and untie. I figured in the classroom, you know, working with pendulums, it'd be easier to be able to, you know, remove it and change different things if it's just taped. And then this is actually what I used as my pendulum here. Trying to fix it. My kids have been playing with this for the past few days, so it's kind of, which is a good thing, I guess, because it shows that kids are interested in it. But so you would tape the string on here and then just tape it here. And what this did is this allowed me to add and remove different weights as I was experimenting with it, much like kids would do within a classroom. My weights are actually just some bolts that I picked up, just some large bolts. That's all those are. I had my ruler to measure my string because I wanted to check different measurements, and then of course just scissors to cut my string. So I figured, you know, within a classroom, we probably want to, you know, we discuss it, and they would probably want to look at different factors that they think could affect the speed of the pendulum. So that's what I focused on. You know, does the length of the string affect the speed of the pendulum? Does the weight of the pendulum affect it? Does the height in which it's dropped affect the speed of the pendulum? So what I did is I put my pendulum on here, and I set my timer for 15 seconds, and I would drop my pendulum, and I would watch it go, and I would count how many times it swung within 15 seconds. Now, what I found to be kind of interesting is that, you know, I started with my 1 foot rope and started with the bucket alone, and I found that it did 22 swings. So I actually counted 1, 2, 3 is how I counted. And I found that with just the bucket alone, with a 1 foot rope, it swung 22 times. So I went ahead and added another, a piece of weight, and found that it was 22 seconds again, or 22 swings. And I also realized that no matter what height I would drop the pendulum from, it would still be the same amount of swings. So that was interesting. And then as I added the weights for my 1 foot rope, it just continued to be 22 swings within the 15 seconds. So then I went ahead and I shortened my rope, excuse me, and I put it to 3/4 of a foot, and started again with just my bucket alone at that length. And my number of swings in the 15 seconds was 24. Added another weight, 24. Added 2 weights, 24. Added 3 weights, 24 swings still. And then added 4 weights, and it was still 24 swings. So, I mean, it was pretty, you know, just right there, 24 swings every time. And then, so I shortened it again, 1/2 foot. So I ended up with, you know, I had half as much as what I had begun with. And I started with the bucket alone, and this time it was 26 swings. So, you know, it went from, at a foot, it was, 22 swings in 15 seconds. And cutting that in half to a 1/2 foot rope, it ended up being 26 swings. And again, it was the same thing. Every time I added the weight, it was still the 26 swings. So that didn't change at all. So as my rope became shorter, the swings became faster. So it was quite interesting to note that it didn't matter, like I said, where I released the pendulum at with each rope length, because the number of swings was always the same. The weight also had no effect on the number of swings. It didn't matter how much I put in there. I'm still fighting this cold after 3 weeks, and it's a pain. My kids actually were playing with this after I was done, and I had bought a huge thing of bolts and actually have another one just like this, and so they were dumping everything into it and swinging it, because they thought in their heads, they thought that, well, it's going to slow it down if I put more weight in there. So they kept adding more in, and it didn't change anything. I even showed them we were timing it, and and it didn't change. It was still the same amount of swings, and it was just dependent on the length of the rope, and that was it. So they found that quite interesting, and they've actually been playing with it quite a bit, which, like I said, is a good thing, because that means, hopefully in the classroom this would be a good experiment to do. So now going to my future classroom, if I were to do this, I would start by taking them out into the playground. I would explain what a pendulum is. It's defined as a weight hung from a fixed point so that it can swing freely backward and forward, and ask them if they can spot any pendulums on the playground. After pointing out the swings, which I'm assuming anyways that they would probably notice the swings, or I would help point those out, we would discuss what would happen if I pull the swing back and let it go. I would let the students, observe this, try it themselves, and I would ask them to count, how many times is it going back and forth. I would have my students, pull back the swings and let it go at different heights, and have them count the swings and observe what happens and discuss it. I would then ask them, what if we put a classmate on the swing? What's it going to do? Is it going to be, you think it's going to look like it's going faster or slower, or do you think there's going to be no change at all? So I would have them test this out, and then observe it, and we would discuss it out there. I would then ask my students if they think that changing the length of the swing, the chain of the swing, would make any difference. And, hopefully I would have a swing that I could easily just throw around the top, so it'll go shorter. And if I could do that, then we would experiment with that and observe as well. If not, then we would just have to discuss it at that time. I would also say, okay, so what happens if when I'm pulling my swing back, if I let go, what happens? And, they would point out that that it's going to fall, and it's, why does it fall? Why doesn't it stay up here? Why does it keep going towards the ground and then back up again? And hopefully, they would, or someone would mention gravity. And again, the book and the standards are saying don't get too technical with the pendulums, so I would probably just stick with an explanation of gravity with that. So then we would go back into the classroom, and I would have them write out what they observed, what they thought as far as what affects the swing of a pendulum. What are their thoughts on weight? What are their thoughts on the length of the pendulum? What are their thoughts on, on where we release the pendulum and how that has an effect on the speed? After they write down their observations, I would have them observe a pendulum just like this one. Again, this was super easy to make, super cheap. Can be taken apart. This isn't even glued. It can be taken apart and stored pretty easily. So I could see this being really useful in the classroom. So I would have them observe it. And, you know, we talk about the questions again. I would just, you know, let them kind of play with it a bit and, you know, see what happens. And then I would break them into groups. And in each group, I would have them have one of these to experiment with. So I would then, you know, provide the same kind of rope, the different weights, something similar to the bucket that I used, so that the weight could be easily changed for them, and the length with the tape. I would have them observe and then record the different variables. Like I said, you know, I want them to look at different ways they think would affect the speed of the pendulum, which would likely be, you know, the length and the weight and maybe even the height that it's released. And sorry, I lost my place here. Okay, so, you know, I want them to look into that, and I want them to, just like I did, you know, write down, you know, what's it do at a foot when I put one weight in? What's it do at a foot when I put two weights in? And you know what, I want them to record those into a table and have that data available. And, you know, do the different lengths and do the different weights and see how that changes anything, or if it even does. Now, this is a simple project, and I absolutely love it because of that, and because I think that it's really interesting to kids, and I think I've seen that, you know, in my own, because of how interested they've been in it, and they're still learning, and I love that. I love it when kids can have fun with a project like this and not even know that they're learning something, which is nice. It makes it fun. Now, if I were to do this within my own classroom, I really wouldn't change a lot. Let's see. I've seen pendulums, you know, when I was when I was researching different pendulums, I did see the way that you can, I don't know if you can see this, but this is just the string put on, you know, around the weights, and it would be a longer one. I just did this as an example. But, you know, this could be the pendulum. And, you know, you'd have to tie and untie and do all that. But this is a different way that it could be done. So you know how the bucket flopping around. And it would allow them to put different nuts on there of different sizes, different weights, like I did. In the classroom too, I thought, you know, why does it have to be a bucket, or why does it have to be the nuts? Why can't, you know, the kids bring in something that they want to test out? You know, maybe they have a toy dinosaur that they want to wrap the string around its leg and, you know, use that as a pendulum, and that could be something at the end that could be done, you know, just for fun, just to keep them engaged with it. I also, but as far as changes though, I really don't think I would change much. I think what I did would work fine, and I don't think there's really much to change as far as that goes. Now, I did see another fun project that could extend this lesson, and it's actually doing the pendulum painting that I was talking about in the beginning. And it's just using one of these frames. They have the string up top, and they have it attached to a just like a Dixie cup, solo cup. And in the bottom of the solo cup, they have holes poked, you know, 1 or 2 holes poked there. And then they fill it with paint. And underneath, they have a big white sheet of paper. And, you know, with those holes in the bottom, the paint's going to slowly come out. And the kids are able to just let their pendulum go, you know, if they want to go in a circle or back and forth, whatever they want to do. And the movement of the pendulum and the paint coming out the bottom creates these really neat pieces of art. And I think that would be a really great way to, you know, to extend this project, you know, as far as their learning, and they also get to do a pretty cool art project. So, yeah, so that's something I would definitely, I think, do within my own classroom. Do something like this, work in the lesson on the swings, and then do the pendulum painting at the end. Okay, thank you so much. I hope you guys have a good semester.